Hey, pre-calc students, Mr. Mitchell here. Today we're going to take a look at derivatives and how to calculate them. We'll focus more later on what a derivative is and where it's used and things like that. Today we're just going to focus on the types of derivative calculations we're going to do in pre-calc. So let's get started. So we have some definition rules type things that we're going to use. So the first thing we need to do is take a look at notation. So we have a function, we have a derivative. So instead of writing the word derivative or the word function out over and over again, we already know function notation is f of x. Derivative notation is f prime of x. So that means the first derivative because there's one prime, because you can also have a second derivative, a third derivative. So if you have a double prime, that means it's the second derivative, okay? Because you can take multiple derivatives and talk more about what that means later. You also do a lot more of that in Calc BC or AB, okay? So taking a look at it, it's a little harder to see the derivative of any constant is 0. And what a derivative is, it's the slope of the tangent line. It's the slope of a tangent line at a certain point, or for that whole function. So the slope of a horizontal line is 0. I think of it that way. So any constant, the derivative is always 0. And if you want to look at the rule, basically you take an x or a variable and you take its power. To find the derivative, you take the power times the coefficient, and then you take one away from the power. I know that's in words, that may be confusing. It may be confusing to see how you go from here to here, but we're going to focus on that when we go down here in practice. So the derivative of the function 3x minus 1. So this is x to the first, right? So you take 1 times 3, and you get 3. And then what's x to the first? You minus 1 from its power. Well, what's 1 minus 1? That's 0. So this is 3x to the 0, which is just 3. And then the derivative of minus 1 is 0, because there is no x value. It's x to the 0 already. So then what's the derivative of x squared? So you take the exponent times the coefficient. So 2 times 1 is 2. Then you record the base, if you will. The base doesn't go anywhere. It's still the base. And then you take 1 away from the exponent. So that's why it's x to the first. Let's take a look at this. So we're going to take the derivative, and we do this for each piece in a polynomial function. So take your exponent times your coefficient. So 2 times 5 is 10. Write your base. Take 1 away from the exponent. So that's a 1. And then take the derivative of this. So 1 times negative 3 is negative 3. X to the first minus 1 as an exponent is x to the 0. And then the derivative of any constant is 0. When you have something on the bottom, you need to write it on the top before you find the derivative. So this 1 over x plus 1, you can write that on top using exponent rules. You make it a negative exponent. And when you do that, then you use the same rule, except you also have to take the derivative of the inside. You have to be aware of that. So take your exponent times your coefficient out front here. So negative 1 times 1 is negative 1. Write your base down, and then take 1 away from the exponent. And then don't forget to take the derivative of the inside. So then we have to use a rule from like here. So what's the derivative of x? Just 1. What's the derivative of 1? 0. All right, so we're going to see some of these get practiced down here. So using some notation, so we want to find f prime of x. So the derivative of any constant is 0. What's the slope of a horizontal line? It's 0. So now we want to find f prime of x here. So our exponent there is 1. So we're going to take 1 times 2, and we get 2. Take 1 away from this exponent. So what's 1 minus 1? That gives you 0. So what's x to the 0? Well, that's 1. So you can write it. If you're going to write every single step down, you're going to put a 1 in there. 2 times 1 is going to be 2. And then what's the derivative of any constant? 0. So then your answer is 2 there. All right. Take a look at this one. You're going to take your exponent times your coefficient. Your coefficient there is 1, so that's 2. Write your base down, which is x. Take 1 away from the exponent, So that's a 1. So it just ends up being 2x. Again, we're finding f prime of x. And then what's the derivative of any constant? 0. Okay. Look in the next one, we're going to find f prime of x. So take your exponent times your coefficient. That's 8. Write your base. Take 1 away. That's 1. Simplify that, it's just 8x. So here's your exponent is 1. Take 1 times -2 is -2. That's going to be x to the 0, right? Take 1 away, you get 0. Well, x to the 0 is just 1, so then that's a -2. Any derivative of a constant is 0. So technically that's plus 0 there. All right. So let's find f prime of x again for this bigger polynomial. And again, the longer the polynomial, it doesn't really change anything. It just makes more work. It doesn't change how you do any of the problems. So we're going to take our exponent times our coefficient. So 2 times 3 is 6. Take 1 away. It's 2. Minus 2 times 5 is 10. Take 1 away from the exponent. Take your exponent times your coefficient. 1 times 3 is 3. Take 1 away, that's x to the 0. And then the derivative of any constant is 0. So when I write my final answer, I don't want to write all that stuff down over again. And I don't ever write x to the first, really. And I'm not going to write x to the 0 either. So there's your derivative in number 5 there. And then we need to find f prime of x here. Take your exponent times your coefficient. So that's 4x. Take 1 away. That's cubed. Take your exponent times your coefficient. That's 9. Take 1 away. So it's squared. Take your exponent times your coefficient. That's 8. And there's an x. Take 1 away. You get x to the first. Or you don't even have to write that. Oops. And then take the derivative. You got 1 times 6 is 6. It's x, so you take 1 away.
Excuse me.
Sorry about that. And then the derivative of any constant is 0. So again, I'm not going to continue to write that over and over again. Once I know that, it's 0. Boom, it's gone. All right. So there's your answer in number 6. So number 7, we get to something a little different. We need to first, this is still f of x. We need to write this on the top. And that's to the first power, but it's a negative. Okay? Let me write it a little bit clearer here. So it's a negative because you took it from the bottom and put it on the top. Negative exponent rules apply there. Okay? So what we're going to do, now we're going to take f prime of x. So this initial step here is not the derivative. I can go back and forth between this and this if I wanted to, depending on when I take derivatives, I want it in this format. If I were doing something else with it, I'd want it in that format. So I'm going to take my exponent times my coefficient. So what's -1 times 3? That's -3. And then I write my base. Take 1 away. Well, 1 away from -1 is -2. Remember, when you subtract 1 from a negative, it gets even smaller, or it gets bigger negative. And then this is what students forget sometimes, because a lot of times it ends up not mattering. But then when it does matter, students mess it up. The derivative of the inside. So go back to a couple questions before. What's the derivative of x minus 2? The derivative of x is 1. And the derivative of 2 is 0. So the inside is just 1, so it doesn't matter in this case, but it's going to matter in another problem here in a couple minutes. Okay? So to simplify, we can get rid of this 1 that doesn't matter. And then when we're simplifying, we want to then get rid of any negative exponents. So I put this back on the bottom, and I got a positive exponent, a positive squared. So there's your answer. All right. Let's take a look at number 8. So again, we have to write it as f of x first. We have to simplify it and put it in a format that I can take the derivative of. So I put it on the top, but I make it negative. I can't just move it on the top and not change anything and just, I don't just get rid of the fraction. You can't do that. You can do that if you make the exponent negative, which I did. Okay. So now we're going to find f prime of x and find the derivative. So I take my exponent times my coefficient. So -4 times -2 is 8. Didn't mean to make a fraction yet. Then I'm going to keep my base. So I just recopy the base down. Take 1 away. Well, 1 away from -2 is -3. And then don't forget, you do need to take the derivative of the inside. So it's the derivative of x plus 3. It is just a 1. Again, that's not going to be true in every question. It is right now because we're just kind of starting out here a little bit. And then I am going to simplify. My 8 stays on the top, and my x plus 3 heads to the bottom with a positive exponent now. Okay. All right, and we take a look at number 9. So we have a square root. So I can't take the derivative of a square root until I simplify it, until I rewrite it using exponent rules. So I want to keep it with parentheses. So what is a square root as an exponent? That's a 1/2 power. All right, again, knowing your exponent rules, 1/2 power is a square root is 1/2. So now I'm going to find my derivative. So take your exponent times your coefficient. So your coefficient's 1. So 1/2 times 1 is 1/2. Keep the inside the same. So I just write my base down, if you will. Take 1 away from 1/2. So what's 1/2 minus 1? That's -1/2. And then don't forget to take the derivative of the inside. The derivative of the inside is 2, right? This is a 1 here. 1 times 2 is 2. And then x to the first, take away 1 from the exponent, it's x to the 0. And then the derivative of any constant is 0. Now we have to go through and simplify a little bit. So what is 1/2 times 2? Well, that's just 1. So I'm going to have a 1 on the top. These will not always cancel out. It just happened on this question. If this would have been a 3, then it wouldn't have canceled out. So I have a negative exponent. I got to put that on the bottom. And it becomes a positive exponent. Then I have one more step. What is a 1/2 power? Well, we talked about this a few minutes ago. A 1/2 power is a square root, or a square root is a 1/2 power. It just happens that it's now on the bottom. And so there's your f prime of x. Last one. So I need to write f of x and simplify it. So first, I'm going to write it with powers, exponent powers. So that's a 1/2 power. Right? A square root is 1/2, but it's still on the bottom. I need to get it on the top. So notice, notation-wise, I haven't taken the derivative yet. This is just using algebra, using exponent rules. So now I'm going to write this on the top. And when I do that, now I have a -1/2. So now I'm going to take the derivative of this. So I'm going to take -1/2 times 1. That gives me -1/2. Keep my base. Take 1 away. Well, what's 1 away from -1/2? That's -3/2, right? -1/2 minus 1 is -3/2. And then don't forget to take the derivative of the inside. The derivative of the inside is just 1. So I know it may look like nothing happened, but you must do that. In the last question, if you didn't take the derivative of the inside, you would have gotten an incorrect answer. So we got a bunch of stuff going on here. Let's take the x minus 4 quantity 3/2 to the bottom and make it positive. I got a -1/2. So I can put the -1/2 out front. I can put the -1/2 on the top, or I can put the -1 on the top and a 2 on the bottom. Isn't that -1/2? Yes, it is. So now we're just simplifying. Again, I got a -1/2. I got a -1 on the top and a 2 on the bottom. So what this looks like, the 3/2, I do need to simplify it. The square root of x minus 4, that's the 2 on the bottom. And then I also have to have it cubed because it's 3/2. That's the 3/2 power. Okay. So if you're having some issues, we have to ask ourselves, is it derivative or is it exponent rules? If it's exponent rules, we've got to go back and review those. Those are Algebra 1, Algebra 2 concepts. Okay, that's why we need to know our exponent rules. All right. So if you have questions, try to gear it towards, well, I'm having trouble with exponents knowing why it's a square root or why it's this or why it's that. If you're having trouble with the derivatives, focus on these questions. Can you take these? Because then it might not be derivative, it may be algebra. Okay. Let me know if you have any questions.